First of all, folks, I'll have to say, look, big well done for staying on task, completing the questions, and getting to me on time. I understand how difficult this is at home, and especially with, well, there was uncertainty about the exams, but I'm going to try and explain that now. So again, congratulations. Keep at it. I'm going to be realistic on my expectations. We're going to do a little bit of new theory each week and continue to practice our programming. The reason why, the examining boards have asked the centres now to provide your assessed grade. So your AS score will come from the work that you've submitted to me. I will be using work that you've submitted into the team. I will release weekly questions. So for example, the questions I start this week, I'll mark them, and those grades will contribute to your overall assessment. So I'm giving you time. I would like you to do the questions at home. Take your time, speak to the team, speak to me if there's any problems, to make sure you score as high as possible. If we do get back to school, there'll be an expectation that I set you a test. I will be using the questions that we have used throughout this lockdown. So if I set questions like today, we're going to look at questions on the bubble sort, etc., and other questions, that's what I'll be using to assess you, because look, it is very difficult, and I can only ask that you try your best. So before we look at this week's lesson, has anyone any questions about your AS grade and how it's going to unfold? No? So we shall start. This week we're looking at, or you're looking at, the bubble sort algorithm. It's nothing new. We've studied it at GCSE. The only thing we're really looking at now is being prepared to be able to read it and write it in a programming exam, even though you're not doing the programming exam. But we're going to look at, theoretically, its strengths, its weaknesses, and hopefully by the end of this week you would be confident if you had to write it on the fly in Python. You would know, you'd recognize it, right? Get my two loops, get my comparisons, get my swaps. There, you're good to go. If we look at our theory notes, and I'm just going to highlight, I'm going to ask you to watch this video in your own time. In your OneNote, there's an excellent video that goes through it step by step, the bubble sort algorithm. We know from GCSE that it iterates through, it uses a nested loop, and it iterates through each element and makes a comparison with the element beside it. And if one element is greater, it makes a swap. So when we come to recognize the bubble sort algorithm, what you will see in recognizing it or coding it is you're looking for a nested loop. You can see here that there's a repeat. And then you can see there's a for loop. So that gives us two loops. Now at GCSE, we wouldn't have studied or we might have mentioned the efficiency of that. And there is a standard way of measuring the efficiencies of algorithm, and we call it big O notation. We don't study it at 2, but we should be able to say that the efficiency of this is what we call n squared. The big O of this algorithm is n squared, because it has to take n loops. So if I've got to iterate through 10 on the outside and 10 on the inner, there is going to be 100 possible comparisons to make in my array. So I've got an element of 10 integers, and in each pass I have to make a swap. That's going to be 10 by 10, that's 100, and that n squared is not efficient when it really comes to computational algorithms. So what are we looking at? Two loops, and we know that two loops is going to give us n squared, generally inefficient. In the inner loop, you will be looking at this, the comparison and the swap. And the swap you'll often see as a temporary variable. So I'm going to put, hopefully we can see some code on screen, and I'm going to upload these after the lesson. What will we look at first? This one. Right, we've got a test array with these elements in it here. You can see it's unsorted. what we would expect is two loops. We're going to iterate through and we're going to compare 5 with 1. Because 5 is greater than the element to its right, we would swap 5 out into a temporary variable, a temporary allocation. We would move 1 to the position where the counter is, and then we would move 5 to the position of the counter plus 1. Bear with me, someone seems to be trying to get in. So we're back to this bubble sort algorithm. Right, this is long-winded, but I'm going to run this to try and show you a talk through. So we're looking at inner passes and outer pass. And inner pass 1, you can see here that it's comparing 5 and 1. And because 5 is greater, it's going to swap. And then it's going to compare 5 with 8. It's going to swap. And I'm going to flow slower than the criteria, but you can see that this algorithm goes through it and it explains at each step what is happening. The inner pass and the outer pass. So we're going through the array, it's printing the number, and then we've got our inner array. And if there's a comparison, this algorithm will actually say, etc., etc., and it makes a swap. So that probably isn't that clear, but let's stop this and look at the code. So I'll upload that one. It just basically is it's a walkthrough, but I'm going to look at this one to look at the actual algorithm. So what you'd expect from this type of function again is your two loops. We need to know the length of the array, and it explains here that look, you don't really have to go to the last iteration, because the time you've got the last iteration, any swaps that need to be carried out will have executed. So it says here it also works, you can go to the whole length, but there's no point for that being extremely inefficient. And again, if we go back to a big O, even though we don't have to do the last n, it's n minus 1, and big O, we drop constants, and it's still fair to say that it's n squared because there's two loops. So first one, iterate throughout the whole loop, and the second one, our inner loop, is going from 0 to the length of the array minus 1, and we're decreasing. Here it makes a comparison, and here is the swap. We're assigning two variables on the fly here, and we can see, pass this in, and it outputs the array. So that's the basic. I'm going to keep this on screen. You can pause it when I upload the video, and it's this that we're going to be implementing in practical programming this week. So you have two tasks, folks. It's going to involve, you need to read through these notes. If you don't grasp bubble sort, read through it. You can look at the Python implementations, and you've got, where are we? Two questions. Both questions should now have, where are they? They should be live. They were scheduled to post during this lesson. And yeah, here we go. Bubble sort task 1 and bubble sort task 2 will be in practical programming. Task 1 is a very, very simple manual walkthrough of the bubble sort. It's only question 1 in this worksheet. So you can open that in OneNote and just scribble on it or type on it, showing at each step how this would be sorted. So write out the list. You think in the first iteration, 45, 32, there's going to be a swap. Write down the stages of each of those for that array. It's only question 1. Question 2, the programming, which is slightly, well, it should challenge you. We want to implement an app using tkinter that visualizes and illustrates the bubble sort. So you can use any of the bubble sort algorithms that I upload or in your notes in Python, but the hard part is coming up with a visualization on screen. The idea that the user can input a set of numbers, and that they can hit sort, you'll have some type of visualization on screen, and then the output at the bottom will be the sorted array. I've suggested that you could use the Tkinter progress bar widgets or possibly the canvas widget to do some type of illustration. You could use the progress bar, to represent the weight of each of the numbers. So, you've got 10, 5, 2, and you could show them moving possibly on screen. Or again, you could use the canvas widget to draw whatever visualization you think would be appropriate. So there's 2 tasks. The deadline, folks, I think it's Wednesday and Thursday, because I'd like to mark them for the end of week review. Right, have we any questions on either the bubble sort or what you're doing this week? Feel free to speak. Turn on your mic and speak.
Said strings or integers? Alphabetical order, sort of by alphabetical order.
Whatever you fancy. I didn't think about that. Maybe in the question, I think I said strings or ints. If you think your app, if you want to do strings, it sorts people's names or places or whatever. But the idea is, that someone will be able to input an array in the user interface, hit sort. There'll be a wee gimmicky visualization of the sort process, and then there'll be the final array outputted. It will require a little bit of Googling. Don't copy the answers. You're not the first people to do these. Try and come up with your own unique spin, but you're trying to learn the bubble sort algorithm. Any other questions? So 2 tasks. If you're struggling, post to the team and help each other out, or I'll give you some help. So again, if I can get a show of hands, folks, we're going to leave this lesson. You're going to start your work, do the best that you can. Joseph, have you a question? No, you're just eager on that.
Sorry, I thought you wanted us to put up our hands if we're okay with everything.
No, well, we're just going to do that now. So look, show of hands, and we will wrap it up, and you can set about doing your theory question and your practical question. Again, folks, take care, and we shall meet again next Monday. Over.